In this video, we show how we can take scenes like this one, which took over an hour to render, and relight them in real time. This lets us do real-time lighting design for feature film production. We can reposition lights, adjust their intensities, adjust their specular or diffuse responses, and many other properties. This is because we numerically estimate values of our illumination model that are independent of lighting calculations and cache these values in a series of images, like those shown here. Our system can be adapted to different illumination models for different productions. Please see the paper for more details on the content of these images. Since the results of the caching process are independent of scene complexity, we can always guarantee fast performance in our relighting engine. For our relighting tasks, it is more important to guarantee interactivity at the expense of some accuracy, unlike many other relighting systems, which guarantee correctness at the expense of speed. Our system is good at handling complicated lights. Here, the user adds a distance fall-off to this light and adjusts the intensity of the light in order to focus it more on the character. Our system also supports two forms of shadows, ray trace shadows and shadow maps. Here we show ray trace shadows. Our ray tracer runs in a separate thread. As the user manipulates the light, the shadow is not being computed, but as soon as they pause, the ray tracer will return the shadow results. This way, the full speed of interaction is maintained for the user. Here we show an interesting light effect, where the center of the light can have a particular color that falls off to other colors on the outside according to a ramp the user specifies. For real lighting purposes, the colors would be more subtle. These colors were chosen to be illustrative. Here is an example of a projection effect, projecting a simple colored grid texture. Here is a comparison of the interactive render with the offline render. Our system can handle many lights simultaneously. Since light contributions are linear, we can cache intermediate results and only evaluate the light that is currently being manipulated. Here we can see a standard key light, fill light, rim light, and bounce light used in production film lighting. In addition, we can add shadows and several other lights. We can still manipulate many lights simultaneously. Our system does slow down proportionally with the number of lights being manipulated concurrently. But even so, our system is still interactive. Here is a comparison of the interactive render with the offline render. Our relighting system not only accelerates traditional light manipulation modes, but also lets us experiment with new manipulation modes. In this example, a user chooses where a reflection falls in the scene by simply dragging the mouse to the desired location. From this input, the system computes the appropriate light position, and the relighting engine shows the result instantaneously. This makes the task of positioning reflections much easier and more intuitive for users.